Well, good morning, everyone. Thanks for being here in our fourth session in our Utility 101 series. This has been an opportunity for us to learn more about the utility market, the utility industry, to help us in our daily lives and product development or sales or whatever it is we do in support of the utility market. These sessions hopefully will help us understand that market better and be able to help do our jobs better and as we talk and deal with our customers. For those that may not know me, I'm Rusty Wiliiams. I am the Business Development Director here at AFL, supporting the utility industry after spending somewhere between 25 and 100 years at Southern Company doing telecom and IT work, trying to help you guys trying to figure out from a product development angle and a sales perspective how to address the utility market. All right, and today's lesson, after soliciting feedback from previous attendees about topics for the session today, we're going to talk about utility Scada systems. And even before we got started, I got one question about, well, what is Scada? All right, so that's the whole idea for today, is to talk about what these systems are, why it matters to the utilities, and how what we do at AFL will support them as they go about their daily operations business. All right, that good? Everybody good? If you got a question, please shout it out and we'll answer it as we go through the slides. All right, well, let's get into the discussion here. And just as a recap, because I know some of you have not been in some of the previous sessions, just to kind of think about how the electric grid is put together and how the utilities have to manage these different pieces. This really falls into four categories, all right? You've got the generation piece of the business. That's the plants where they generate the power, the nuclear plants, the coal-fired plants, hydro, or in today's renewable terms, wind farms, solar panels, or other means of generating power, all right? And then they're going to connect that power that's being generated through the transmission grid, the bulk power, high voltage, high capacity grid that transports that power from the generating plants to the different areas around that's being served by the utility companies, go through a substation where they'll transform that power from a high voltage to a lower voltage, then get it into the distribution system, which is what you see in your neighborhood, the wires that go down your street serving your houses or the businesses in your area. Sometimes they're underground. Most of the time in this part of the country they are overhead, but that's the distribution business, the distribution part of the network where you've got the lower voltages to serve the house. All right, then you've got the transformers on the pole outside your house to convert it down even further to, in the US terms, 120 volts, 240 volts to run your appliances and the things in your house. All right, so each of these parts of this electric transportation, if you want to call it that, has got to be managed by the power companies, your local electric utilities. So how do they do that? How do they manage those? How do you think they managed them 50 years ago? This is your part of the Q&A time. How do you think the utilities would manage how this grid operates 50 years ago before the days of computers?
Wait till there's a problem. Someone reports it.
That's one way, absolutely. They would wait until somebody called to say, hey, my power's out. Or, hey, I see your substation on fire. Or, the poles are laying in the road, or whatever it happened to be. They would wait. Now, some utilities still do that today, and that's interesting to see some of that in the press. But that's a lot less likely nowadays. So, what else? What other ways? But without the computers to kind of monitor that, it's difficult to understand that, right? So, they need that information, but they have people out, right? They would have people at the generating plants. They would have people at the big substations just to monitor what's going on the wall, or look out physically out in the yard and say, hey, it looks like something's going, there's a fire, or the wires are drooping, or where the relays are chattering, right? There was no way to sit in some kind of central command center and know what was going on. So you had to have people stationed in a lot more places than they do today. But as the technologies progressed, then the utilities have been able to to put in pieces of software, to put in some technology out in around the different parts of this grid to understand better what's going on. But as you can imagine, as with any other business, just like with AFL's business, there are so many data points to manage. Just if you take just one substation or one generating plant, there's just so many pieces of data that come from that it's hard to manage. Even if you had a screen like this sitting in front of you, how many people does it take looking at this data to be able to make sense out of it? But then when you compound that with, you don't just have one substation or one plant, you've got dozens of plants and hundreds of substations and thousands of line devices that you're trying to monitor, and you've got to keep it all in perfect balance, or the power's going to go off, or the lights are going to dim, or you're going to blow up a transformer. Then it becomes real important to have the technology to be able to do that for you. The humans are still involved with it, but the technology is getting better and better. But you've got to have that data for the good decision, to make good decisions, to run your network as efficiently as possible without the lights going out and without blowing up equipment. Because you'll blow up a substation transformer, that's hundreds of thousands or millions of dollars that you've just destroyed because you weren't able to manage the network. So how do we do that? How do they do that today? Well, really, it's not just a system to monitor that by itself. It's part of the full integration of business services for the utility. If we kind of follow this little diagram from bottom to top, these devices are the devices that are out in the field. All right? It could be the meters. It's the RTUs that are in the substations or out on the distribution transmission line. It's the devices in the switch house. Those devices have got to talk back to some central location through a network. If you've sat through some of the previous discussions we've had, these sessions we've had, we've talked about the criticality of the network, because none of these systems work if you can't talk to them, if you can't get that data back. All right, so the networks are key regardless of whether they're fiber or they're wireless or they're whatever. You've got to have that connection back in to your computer systems, your Scada systems, your control systems, and then ultimately you feed them all the way back up into your business systems, because if you're trying to manage say the power being out in an area, it'd be nice to know what customers were out. Or it'd be nice to know when the customer calls me to tell me that their power's out, I can relate that to a physical aspect of my electric network, and then be able to do some analysis and decide, hey, I've got a problem. If enough people call in a given area, I can use the analytical capability of my systems and say, you know what, based on all these guys calling, it looks like it's either this device that's failed or this switch that's opened, and be able to manage your workforce a lot more efficiently is send a guy to one place instead of sending 14 people out to try to define, to find where the power might be out, where the tree's down or somebody's run into a pole. So the integration, it's not just a SCADA system by itself, and we'll define what that is in just a second. It's not these operation systems by themselves. They integrate with everything else that goes on with the business. Your billing systems, your customer information systems, anything that you've got. They want to integrate all that together so they can maximize that data. That makes sense? All right, so let's talk about what SCADA is. Some of you may have never heard the term. Some of you may have heard it and not known what it was. SCADA, the acronym, stands for Supervisory Control and Data Acquisition. All right, that's a generic term that you will hear used a lot in different industries. That's not just an electric utility industry. That's a term that's used in manufacturing, it's used in other closed systems. You look at the definition here. What does it tell us? It's just a generic term referring to some computer system that monitor and control industrial infrastructure or facility-based processes. All right, just based on that one definition, off the cuff, what else What other kinds of systems do you think would fall under that that you could call a SCADA system? What kind of systems would be managed by having information fed into a computer system to be able to control it?
For utility?
Anyway, not just utilities, any business, any industry, any facility. Can you think of something?
I think of just like manufacturing control systems.
Manufacturing control systems is a great example because, just like this plant out here that's making cable, there's a lot of computing capability installed all the different stations along the way, and that a material is being fed into the process or the speed that the cable's being pulled, and that's all got to be within a certain tolerance, and you're going to feed it back and speed up or slow down motors or stop the process if you run out of materials going into it. It's a closed process that manages that. Then that is a SCADA system, and we'll talk about that a little bit more in just a second.
Like consumer Procter & Gamble's, those type of things, where they're looking at marketing data of who's buying what, where, and supplying certain customers certain products.
Maybe kind of. I could take a stretch and do that, but if you could turn that into the products they make, and how they make those products. There's a few others, and we'll go through some more lists, but there's a lot of different things that could fit into that category. Keep thinking about that. We'll talk about it more. You may have heard the term distribution automation if you've been around the utility business. That's just a process by which they go in and put these computer-controlled devices out on the distribution network, out where you have your switches and your breakers and capacitor banks, so that they can get data from that point and initiate some action to that point through the network. Rather than having to send a human in a truck to open a switch so they could go over here and close a switch to be able to backfeed the power because a drunk car hit a pole and knocked the power out in an area, they can do it by computer. And if you do it by computer, it's obviously a lot quicker, and it can be done in a safe manner, and you just got much more control over your network. You can do the same thing on the transmission network. There's just not as many devices, and the utilities have done a lot with the transmission grid in the past just because of the criticality of it. But there's more devices being installed, so you've got more information about the transmission grid. And then lastly, you may have heard the acronym RTU. Maybe, maybe not. Remote Terminal Unit. That's basically a computer, a processor that you put out in your network to be able to read your data, to set your set points that you want to be able to put into your network, and initiate some controls. So that's your distributed intelligence. That's your computer capability that you're putting in your network. And again, we'll see examples of that in a minute. But for me to be able to open and close a switch on an electric distribution network, there's got to be some intelligence out there, some computer chip that can read the signals, translate them, and turn it into some action, or read from a sensor and feed it back upstream. That's all that is. It's just some distributed computing capability. So SCADA and RTU are the two terms out of this page you need to make sure you remember, and we'll kind of beat it into our heads as we go forward here. Questions? You okay? Now, I ask you what it might be used for. Here's just some examples. You may think of more once you kind of understand it a little bit better. Obviously, the electric infrastructure. How about water and sewage systems? I'm going to give you an example of that in just a minute, just to kind of help beat this into our heads, right? It's a closed system. You got pumps, and you got valves, and you got consumers that you've got to control those systems. Building systems, lighting systems, HVAC systems, particularly in buildings today, high-rise buildings, hotels. A lot of those have systems. Well, think about your home, your air conditioning and your heat in your house. That's a good example of a very simple SCADA system. You've got a thermostat that reads the temperature. You set a desired temperature, and then that thermostat, which by the way is an RTU because it's got some intelligence built into it, will initiate an action based on the information that it gathers and the data that you put into it. Same thing for large buildings. Manufacturing we mentioned already. Transit systems. Think about trains, subways. You've got to control those things. You don't want those things running into each other. So you got to know where they are. You got to be able to control the tracks. You got to be able to communicate with the trains. That's another good example. Traffic signals the same way. So when you think of SCADA generically, it could fit any of these. But we're going to talk specifically as we go forward through the day about the electric system. And I'm going to give you one water example just to help us here in just a second. So what does the SCADA system do? We're going to get data. There are data points out there. Just think from an electric network. What was some information you think the electric utilities would be interested in getting about their electric grid, their distribution network?
Usage rates at certain times of the day.
Okay, so let's just say metering data, the usage data from the consumers. And I'll stop there and see what other kind of suggestions you've got they might want to know. Power quality, right? The reactants, capacitance. In the summer when a lot of air conditioners kicks on and the motor starts spinning, it kind of does some goofy things with the reactants and capacitance in the network. That's the reason capacitor banks are out there to counterbalance that. What's some more simple things? I mean, maybe just kind of thinking, going over the simple stuff. I want to know if the power's on, or where is it off. All right, so I can do that in a lot of different ways with this type of a system, with the meters or with the devices I put out there. I want to know what the voltage is. If it's supposed to be 12 kV on this distribution line, I'd like to know that it's actually 12 kV. Because if there's a lot of load on the line and it gets, one of these days like today when it's going to be 100 degrees and everybody's got the air conditioners on and everybody's pulling a lot more load than normal, guess what? The voltage level has a tendency to go down. And I want to know what that voltage level is, especially if I've got trouble spots. And you can kind of do the math and work backwards to the current flow. You may be more interested in voltage or current, but you can measure both of those. So those are very simple things, and then you get into more complicated things like the capacitance and reactance and all the balances between the phases. You see 3 phases on your distribution lines. Well, they need to be balanced for system purposes. So I'd like to know if phase A is pretty close to phase C, and if it gets really out of balance, I need to go out and be doing some changes to the infrastructure. That's the kind of information that these systems will provide. All right? It will give you the instantaneous reading, and you can feed them back into your computer systems, and you measure that over time. And I'll find out that every July the 4th, when July the 4th falls on a Friday, that I have the highest usage of any other day of the year. I made that one up, but that's actually not completely made up, because when I started with Southern Company, again, whatever that was, 98 years ago, I was in distribution engineering, right? Before all of these systems were in place. And it was in kind of southeast Alabama, kind of rural area, but there was a lake, a nice big lake where people go fish and camp and all that. People had lake homes. Every July 4th, we had trouble in that area because of the demand. I mean, any other time, there's very few people there. The loading was very light on the network. But when everybody went on the 4th of July, I don't know why 4th of July as opposed to Memorial Day or Labor Day, everybody went on 4th of July. We had trouble. In fact, we sent crews down there basically and had them on standby. So if you've got a system to be able to help you figure that out, that would be nice. And I would want to do something proactive as opposed to waiting to try to help that out. So if I've got that data over time, I can do that. The inefficiencies and other things. And hopefully, in the end, we were able to do all of this with a lot less people and provide a lot higher quality service. And I mentioned earlier, before these systems, we had people manned in substations. That's where they went to work every day. Now, there's nobody mans a substation. In fact, there's some generating facilities that have nobody at them. Now, obviously, there's nuclear plant, you've got people, but at a hydro, at a dam, there's a lot of those that have nobody there. that they're all controlled remotely because of these kind of systems. All right, so here's your first diagram of the day. All right, this is a water system. Just kind of think about this closed loop system that we talked about earlier and how we can control and look at the different parts. All right, you've got the Scada program running up on the computer. You've got these programmable logic controllers, or what's another name for those we've already mentioned this morning? RTUs. That's where your intelligence, your distributed intelligence, are in these programmable logic controllers. You've got a pump. You've got a storage tank. You've got a sensor right there that measures flow of the water. You've got a sensor right there that measures how much water is in that tank. Nice, simple, but closed system, meaning there's nothing else that's got influence. Well, you could get a backhoe in there and dig through the pipe, but other than that, there's nothing else influencing that. Okay? So pretty simple, all right? Now when you think about the different piece parts, we'll break it into just 4 components for you to think about. One is you got to get the data acquisition part. So you've got to have a sensor out there or a relay to be able to get that information back. I want to know in that previous example, and we'll show it again, how much water is flowing through a pipe. Or for distribution electrical systems, I want to know how much current's flowing through a particular part of my network. Or I want to know how fast the cable's running through the production line. You've got to have a sensor there, some kind of device that's going to give you that kind of information. All right? I mean, that's been done for a long time. I mean, again, in the early days of some of these systems, it was very kind of rudimentary, for some of these networks, some of the AT&T and Verizon sites that the network services guys go in. When you open the door, there's an alarm. You go in, you want to know how hot it is or cold it is inside the building. It gets too hot, the equipment starts dying. That's the kind of information that these guys are needing. But you've got to have those sensors to be able to do that. Got the RTUs we mentioned earlier to be able to collect that data from the sensors. You've got to have the network to communicate that data back upstream. And then you've got to have these SCADA masters to do something with the data once you get it. Having the data is just part of the battle. The other is what are you going to make, what are you going to do with it? How do you make sense out of that data? All right, so let's take that back to this diagram and see if we can figure out the piece parts. We already decided where the RTUs were, right? What about the sensors? Where are the sensors? We've got that one, and we've got that, right? We want to know how much water's in the tank. We want to know how much is flowing through. And you've got a valve over there, I didn't point that out earlier, that you can open and close depending on what your needs are, okay? So that's the first part of it. That's where you're going to get the data. All right, we said those were the RTUs. In this example, this is the network. We're not dwelling on what that is and whether that's in the same room or whether that's across a state or whether it's fiber optic network or whether it's a wireless network. It's just a connection back from that RTU back to your computer system. And then that's your SCADA master. That's what's going to take all that data and try to make sense out of it, present it to you, the human, in a form that I can digest it and then do something about it. Okay? Now, does that make sense? Sort of simple, sort of not if you don't think about it, but you kind of see, kind of the essence here of these systems. Now, if you think about the RTUs, and again, this is getting a little bit lower level here, but again, to make sure you kind of understand, as I was mentioning earlier to the example for the network services guys out in the networks, you've got all these contact closures to know when somebody's opened the door. You've got the sensors to know what the temperatures are. You've got the alarms coming from the equipment that you're going to feed it into this RTU of some sort. This is just one I found a picture of that helped us kind of look through this. And you're going to feed it through these interfaces in the back of that RTU, however it's presented to you. Could just be a pair of wires for a contact closure. It could be an Ethernet connection coming from some piece of equipment. It could be one of several formats that you would run those wires back into this device for it to then, again, this is the RTU, so it's got its intelligence, manipulate that data and send it back upstream for you. All right, so think about that just a little bit. Does that make sense? That you've got that kind of a device out there? And again, it's in these locations. If we've installed fiber with a utility or a carrier into a hut on the side of a highway or to a fiber regen site, you've got one of these devices in there. There's something like that in that building, in that cabinet, so that they know what's going on. All right, I'm getting a lot of blank looks. Is it okay? Everybody kind of see that? And again, it could be a lot of different protocols, a lot of different physical connections, but the idea is you've got to get from those sensors into the RTU somehow, and that's kind of the back view of one of those RTUs to be able to do that. All right, so let's start thinking about it from the electrical side just a little bit. Again, this is a different view of what we've just looked at with the water example. But you've got that Scada system setting somewhere. Where is that probably setting for an electric utility? Where's that Scada master probably setting? Where's it physically located? An operations center, a control center, a distribution facility of some sort. Could be a data center. Probably not. It's probably an operations kind of a center where those computers are located. And then you've got to get out from that control center, operations center, out into the world. And how we're going to do that. That network, that cloud we talked about earlier. Again, it could be radio, could be cellular, could be fiber optics, could be one of several technologies. It doesn't matter which one you use as long as you've got the right connection. So if we're talking about utilities, why would a utility pick a fiber connection versus a cellular connection? What would be the difference? What do you think would make them go one way versus the other? Any thoughts about that? Well, that's two good points. Speed was one of his points. How many of these things do I have? And oh, by the way, do I have cameras out there where I need to see video? That's a lot more bandwidth I got to have. Reliability is going to be one of them. Which one do you think would be more reliable? Ooh, that's a good debate. All right. So what if I wanted to use, say, AT&T Cellular for that connection from my substation or my Scada devices, as opposed to installing fiber optic cable? Which one do you think would be more reliable? Probably 98% of the time, both of them are going to be working. But, the cellular companies, particularly in the U.S., and it's a different debate. In fact, this is a debate going on in Washington and has been going on for a long time with regulators about, how reliable exactly are the cellular companies. What happens when the ice storm hits and the power's out for 10 days? A lot of times the cellular sites lose the power. They don't have generators there. If their networks fail, if they have a physical problem with a hurricane or a tornado, their order of priority might not be the same order of priority as the utilities when they need to get their power back. So there's reasons to do it, but there are cost implications. We mentioned cost earlier. There's pluses and minuses. It's capital cost versus operating cost. There's a lot of things to think about when a utility has to decide on a network. And honestly, there's no one answer. There's no right answer. We want them to always buy fiber cable, right? But that's not always the answer. If I'm installing a metering system, a new AMI metering system, I'm not going to go in and put fiber. I mean, that's just, we look at it from a cost perspective and logistical perspective. You can't really justify building fiber all the way to every meter just to read the meter. But if I wanted to do video, or I wanted to do internet, if I wanted to provide triple play bundled services like some utilities do, I'm not going to do it over cellular. I'm going to have to get fiber in there. So it's just going to depend. And then lastly on this chart, kind of get you out to that RTU and to those devices out in their network. All right? A little bit more common type of a diagram. Again, nothing's as simple, right? It's not a simple straight line and two endpoints. It's much more complicated than that. And I'm not going to go through this whole thing, but just kind of help you understand that these networks are a lot more complicated than just getting a piece of fiber from point A to point B. I mean, you will have, a lot of the utilities have an optical network. You've got a ring built out there, and if I put in OPGW, then I've got that fiber into all of my substations because I'm going along the transmission line and I've got my fiber at the substation or at a generating plant. Great, opportunity there to pull that data, send it across the fiber network. But I've got to reach out to those edge devices somehow. This particular example is just kind of showing kind of a wireless kind of a connection, but somehow I've got to touch all those devices out there and be able to control them and get the data from them. And oh, by the way, I've got to talk to wind farms that I've never had to worry about before, and I've got to worry about solar farms, and I've got to worry about manufacturing plants that's got their own generation, and I've got all these things that I've never had to worry about that we talked about in our last session that I've now got to manage as a part of the delivery of the electric power. All right, so here's a few examples. I asked you earlier what you thought they got. So we'll see how many of these we mentioned earlier. So kind of basic things I know we did mention. We want to know what the voltage is. We want to know what the current is. We want to know what the reactance or capacitance is. We want to know about all these devices out there, these switches and breakers and reclosers and all these devices. We want to know, are they open? Are they closed? Are they working? Are they not? Are the capacitor banks online, offline? We've got to know all of that. Customer devices. Today, we don't talk to transformers. We talked about it in the smart grid session last time. But I think it won't be too far in the future where the utilities will need to talk to the transformers hanging on the pole. They'll need to talk to street lights. Now, just for one plug from those of you that were in that session, I mentioned, hey, utilities may want to talk to street lights. About a month ago, Chattanooga's Electric Power Board, they've been real big on fiber to the home and providing, internet capabilities to all their people in the city and all that. Well, they made an announcement 3 or 4 weeks ago that they're going to go in and replace all of their street lights in the city. One, they're putting in LED lights for energy conservation purposes, but most of those street lights that they're putting in are going to have communications capabilities. So that's a real example of a city really wanting to talk to street lights. And now if I'm talking to 100 line devices, that's one thing, but if I'm talking to 100,000 street lights, that's a completely different network I got to worry about. It just compounds itself to the question of why fiber. There's just so many of these devices that it's just going to drive the usage and bandwidth way up. Metering we talked about, outage data we talked about, I'm going to mention that. One thing we haven't talked about, I called it 60 cycle waveform. It's just probably a better generic term is just analytical data. The utilities never want the power to go out. We as customers don't want it to go out for sure. I mean, our life depends around electricity. We can't cook or watch TV or, get on the computer or whatever unless we have power. If the utilities can get in a position where they can see problems before they cause an outage, that would be a much better state than where we're in today. So if they can measure at these sensors we were talking about, if you measure voltage and all, but let me see what that 60 cycle waveform actually looks like on an analyzer. And I watch it over days, and I take a reading every 5 minutes for days and weeks and months. Then I know what it's supposed to look like at this point on that pole. All of a sudden, something happens and it gets out of tolerance. Not an outage, but the waveform gets goofy. That's a technical term, goofy. Then that would set off a flag. And the guys in the ops center could go, instead of responding to an outage, they go, well, something's going on at this place. causing a problem. What might it be? It could be a tree limb brushing against the line. You know, the trees have gotten, maybe the limb had broken or it just grown into it. Might have been a squirrel, you know, running across through there that caused the waveform to kind of, you know, act goofy for a little bit. But if it's something like a tree or it's getting overloaded, then they can go do something, cut the trees back, you know, shift some of the load around before it causes an outage. That's the real analytical aspects of this that the software really hadn't caught up with the hardware here yet, but you're going to see more of that as we go on. And then the substation switch houses, everything is computerized, everything's got an Ethernet connection, and they want to talk to every switch and relay and meter and everything in a switch house. All right, so what does that mean to me as a consumer? You know, I'm the electric customer. Well, one is the power company now can remotely control a lot of these devices. So they don't have to wait for some guy to leave home in the middle of the night, go get his truck, go to the warehouse, get his material, go, you know, get in position, go look for where the outage is. They can control all these breakers and switches and all automatically and remotely. In fact, if they would allow them, the computers could manage it all by themselves and then tell the humans what they've already done. Now, a lot of utilities are scared of that. Why do you think there's some concern about just letting the computers handle it?
Well, that'll do a lot of jobs.
Well, I mean, possibly. You know, the job situation, you know, I contend personally that the jobs don't go away, they just change. But that could be part of it. But there's a real concern that some utilities have.
For safety, you could have a wire down on a car or something.
Yeah. There's safety. That's the reasons you hear a lot is, you know, you'd like for a human to say, okay, let's do this before the computers automatically do it, because you could have a situation where, you know, a line across a school bus, or, you know, you just imagine something like that happening and the bad press that would come along with that. But those systems are capable of that today and will only get more so. Be able to automatically, you know, turn you on, turn you off, without having to send somebody in is another thing they can do. Billing, your power quality we mentioned. So there's a lot of these things. Asset management I didn't mention explicitly, but it's nice to know where your transformers are, where your poles are, where all the different pieces of equipment. Or if you're doing an engineering job, you go, a transformer to substation, I think it's this brand, but I might be this brand, or maybe this size, but I'm not. Sit down your computer, call it up. Just find out exactly what it is before you go about doing what it is you want to do. All right, so that's kind of the network view of that. But there's one thing that's really bothering a lot of regulators in particular about giving this kind of capability to these systems. Let me stand out of the way. You guys are trying to read that, sorry. What happens to anything that's connected to a network, to the internet? It automatically becomes vulnerable to people hacking into it. So systems that have never had that kind of capability in the past that are critical to us, like power systems, now all of a sudden we got to worry about some guy in China hacking into the system and doing something. I mean, what could they do if somebody hacked into these SCADA systems that control water or electricity or sewage or other things?
Shut it down.
Just shut it completely down. What else could they do?
Blow it up.
Blow it up. That would be a lot worse than shutting it down. It would be a pain in the rear for somebody to hack in and turn my lights off. But if they figured out a way to work through the system and get into a nuclear plant and blow up something in a nuclear plant, that's probably not a good thing. And that is, you know, when you provide more capability, then the possibility of that comes along. And you know, not too long ago at Southern Company, just as an example, when this issue first started coming up, we'd hire firms to come in. I mean, there are firms out in the world that make their job, you know, make their money coming in, hacking into your systems legally. not illegal, but doing it legally. We had one of the best security experts on staff at Southern. So the first time we did this, we told him, we turned him loose and said, hey, go see what you can get into. Sitting in his office, go see what you can get into. And what he brought back was scary. Places you never thought you could get. He would take a screenshot whenever he got into those kind of places. He'd just take a screenshot to prove that he was there and came back, and you're going, what the heck? You know, can you really do that? And the answer is yes, if you don't take the right precautions. They can be protected, just like protecting your identity with, you know, cell phones and credit cards and all that. You've got to be smart about it, and there's ways to do it for SCADA systems as well, okay? But again, this is a new phenomenon for the electric business. I mean, we've been providing power for almost 150 years, and we haven't had these SCADA systems, and what we've had over the last 20, 30 years has not been interconnected to where you could get into it. So now, all of a sudden, we've got to worry about this. And we talked about it earlier about what can they do, but here's this, you know, physical threats. You know, can they, you know, bring a bomb in? You know, I don't know. But a SCADA system I could help if I've got video surveillance. I know when people open doors. Insider threats, they've always been there. You got disgruntled employees, they can do whatever they want to do. Incompetence, people are just stupid, you know, and do stupid things. But guess what? That happens even with SCADA systems. When was the Northeast Blackout? 2003? It started in Ohio and went all the way through New York City, and is it that long ago, 2003? That's what's coming in my mind. That started in First Energy's territory in Ohio with a tree falling on a transmission line and a guy sitting in First Energy's control center not acting properly on the information that was presented to him through his SCADA system. And then it started snowballing because the grid's interconnected, and it was one of those days, if I remember, it was a hot summer day, and this and that, and all of a sudden this line tripped and another line tripped, and it just started snowballing on him. And everything was dark from there all the way up through Canada and through the Northeast corridor. So, you know, I put incompetence in there just because that can happen. But you can get viruses. I mean, you could, if you've got a network-connected, smart, computerized device, somebody could put a virus in there. Hackers, denial of service attacks. I don't know if you guys have ever follow IT security or anything, but one of the most prominent ways that the evildoers, as President Bush called them, try to wreak havoc on the internet targeted at, you know, a certain business or a certain group is what is called a denial of service attack, where basically they just flood requests into your web server. Millions and millions and millions of requests over a very, very short period of time, and basically just bog your network down. That happens, all right? You know, but there's ways to fix it. But now all of a sudden we could do that with a SCADA system. What if I found out a way to hack into your SCADA system as a utility and then launched a denial of service attack? And you have to shut your SCADA system down until you can get it fixed, and now I have no visibility into my network. That's not a good thing. Oh, you see the other things there. As we said, it's everywhere now. It's not just one piece of it through the whole network as we put it in across the infrastructure. And then most of these we got earlier. You got blackouts, you got damage, you can lose data. You know, losing data would be an inconvenience. You lose metering data, then that's a loss of revenue. So there's things that can happen. And it is real. I mean, you know, we see things going on in the cable market with the Chinese, but, you know, that's a passive device. That's just a piece of cable. When you think about electronics, there's a lot of debate in the industry now about data networking equipment, routers and switches coming from China, having code embedded in the memory that would actually have some of these viruses, or actually more specifically just kind of sitting there collecting data that it can feed back to the mothership, wherever that happened to be at some given time. And it'd be done in a way that was undetectable. So what if that's done on the electric grid? What if I put a router in my electric grid as a part of these SCADA systems that's got that kind of bug in it? then they all of a sudden know where everything is in the electric network. They know how everything's put together. They know how to get into the different pieces. And at some time, whether it's a war or some kind of political upheaval, somebody might decide to do something with it. So if you read, it's interesting reading if you get to looking at some of that and are interested in that. Just a visual example of what we just talked about. This is just a tad blurry, but I like this diagram. And I'll blow through this right quick and see if you got any more questions. All right, for this diagram, generating plants, transmission facilities, distribution facilities, customers, and control centers. Okay? Generation, transmission, distribution, customers, control center. All right? So for the first time ever now, all of these devices will be connected. So you've got a connection over to your transmission from your control center. You got connections into your distribution devices. You got connections to the customers. So if anybody wanted to, start hacking into it, if they could get into any piece of it, then they've got the capability of going through. So again, I showed you that distribution, metering of the customers and the control center. So what if I wanted to figure out a way to worm my way through this? There's a lot of people concerned that the most vulnerable link is on the metering side. So what if I figured out a way to hack into my meter at home if I've got one of those smart meters? And then work my way back upstream into these Scada systems and then back out into these generating plants. So there's ways to do that. We've never had to worry about that before. All right? But the bottom line is this kind of capability is going to stay there. They're not going to go in and completely disconnect these. They're going to find ways to protect them. And for people, for companies that are making equipment for their networks, then they've got to figure out a way to be able to do that for them securely. Now again, for us, for cabling, that's a pretty passive device, so there's not a whole lot we can do. And with the companies that make the electronics, the RTUs, the routers, all of that, then that's a big challenge. And the federal government is really pounding on the utilities to figure out a way to fix this. So again, I encourage you to read some of that. If you read any of the information coming out of Washington about things that are going on at FERC, the Federal Energy Regulatory Commission, there's a lot of activity related to this today. The federal government doesn't think that the electric infrastructure is secure. And if the utilities can't figure out a way to prove that it is, then the federal government, in all its glory, is going to figure out a way to do it for the utilities. And we never want that, right? All right, questions about that? The whole idea is to keep the lights on, right? That's the whole goal of all of this, is to understand the health of your network and be able to keep the lights on. All right, so what did I confuse you about? Did I blow through something too quick for you? Sure.
So there's lots of questions, there's concern, as technology moves on, etc. How does this impact us? What's our role in this? How can we play a part or do something in this area?
So what does it mean to AFL is the question. From a security perspective, I don't know that there's much AFL can do, okay, when you're looking at that. But when you look at it from a network perspective, how can I help the utility connect all these devices together to be able to bring all this information back? Then we're going to have a big play in that. And again, that's a different conversation for a different day, but when you look at the networks that are probably going to evolve for the utilities, that are evolving, there's going to be an optical component to it. Either just the core, the high-speed, high-capacity core is going to be optical, those rings. I think it's going to go further out into the network. Again, I personally believe that connection to that end device, to that switch or that sensor is probably going to be wireless for most companies. Unless you're doing fiber to the home kind of a network, it's probably going to be a wireless connection. But what we need to do is help the utilities figure out a way to get that fiber as close to that wireless device as we can. Much like the 4G build out for the carriers that the network services guys are doing. They're building fiber all the way to the cell site now. as they convert to 4G because of the capacity requirements. We'd love to be able to do that for these SCADA systems because you've got a wireless transmitter somewhere that's going to talk to all these meters or all these line devices. So as we get fiber out into their network, if we can get it all the way to that transmitting device, I think that's the best we can do from a network, from a cable perspective, from a physical cable and accessories perspective. The other part is we've looked at the capability of providing full network solutions for the utilities. A lot of these guys have small staffs and don't know how to put this stuff together. If we've got the capability of sitting at the table with them and bringing other partners to the table or other capabilities to figure out how to put an optical network together with a wireless network and have a complete network solution for them, I think that's an opportunity. What did I miss? Ungwin, you think of anything else I missed? And there are a lot of the utilities that are asking just that. It's interesting. I've been a little surprised, still being relatively new, that a lot of the smaller utilities will call the agent or call AFL because they know we make cable, and go, "Hey, I want cable." But they don't know what else they're going to do. They don't know what they're going to put on it. They don't know. And so when we get involved, Ungwin and I and the other utility sales guys get involved, first thing we do is sit down at the table with them and say, what are you trying to do? What applications are you going to run? Are you going to do metering? Are you going to do distribution automation? Are you going to do all these other things? And then help them select a network architecture that's going to help them accomplish their business objectives. So I think that's that kind of value add kind of capability to be able to, almost a consultative kind of a capability to help them understand the implications of their business decisions. It's not, hey, let's go build fiber. It's, here's what I want to do from a business perspective. Now let's figure out a way to do that technically. And you can always figure out a way to do it. And hopefully it'll always involve fiber optic cable and accessories and test equipment and the other things that we do. Our conversation don't go very far if it doesn't involve cable. And we have had a few of those conversations. That's fine. We'll go find the next customer.
Rusty, if FERC has come through and said to the utilities, you have to have these securities in place by such and such a date, or we're gonna put through regulations or whatever. Do you know that, or who knows?
Yeah.
If they've done that already?
Yeah, the question is, what is NERC doing from a regulatory perspective? Is there mandates and timelines? The short answer is yes. It's referred to as, you've heard the phrase NERC CIP, NERC CIP, Critical Infrastructure Protection Regulations, where they are evolving the regulations from a federal perspective that the utilities are supposed to adhere to. They're up to Rev 5. I think Rev 5 of that is now in place, working on Rev 6, and it's ever evolving, more and more stringent as each step goes along. But in good federal habits, the rules are not black and white. It's like reading the IRS tax guides. All right, the utilities have room for interpretation. Even what they classify as a critical asset, different utilities, some want to be very, very conservative and will have more. Some utilities don't. They'll be push the envelope a little bit and won't declare a lot of things that are, that would be critical somewhere else, critical. But it is a FERC, Federal Energy Regulatory Commission, oversight from the federal government, and then NERC. It's real confusing. NERC with an N is the North American Electric Reliability Council, who is the group that's responsible for operating the grid and creating these regulations and making sure the utilities mandate them. It'll be ever evolving for our lifetime anyway. And even if they thought they got it secure, somebody would come up with something trickier or smarter or whatever they'd have to figure out a way to fix.
The vendors for Scada type systems, are these homegrown,
So who are the Scada vendors? They're, I would say in times past, a lot of them were homegrown, but today they're too complicated to do that. GE Harris is probably one of the ones I see most often. Siemens makes a system as well. Those are the two I see more than any others.
So they'll send somebody in to look at utilities infrastructure and say we can do this. We need to have a system that can monitor a relay. We're going to need to make these upgrades here and there for us to do that.
Right. So if we go back to this simple diagram, the GEs and the Siemens will make this system. The software to make it all work. They may or may not provide like the RTUs, maybe some standards-based solution where you can buy anybody's RTU, but you got to do it in a way that meets the requirements of that software and that system. And they'll talk about what kind of connections and speeds and all that kind of stuff. Any other questions? All right, well, thanks for being here. And if you do think of something later and want to ask, just shoot me an email. I'll be glad to talk to you about it. And if you've got another topic you'd like to see at some point in time, just shoot it to me and be glad to do it. You guys have a great day.